Today our topic is redox reaction. Before we begin, don't forget to like and subscribe to our channel. So let's begin. A redox reaction is a reaction in which oxidation and reduction occurs at the same time. Oxidation is simply a loss of electron, addition of oxygen, removal of hydrogen ions, removal of electropositive elements, the addition of electronegative elements, or an increase in oxidation number. Reduction, on the other hand, is a gain of electron, removal of oxygen, an addition of hydrogen ion, an addition of electropositive elements, a removal of electronegative elements, and a reduction or fall in oxidation number. Now, from the example, which is a reaction, the first example is a reaction between carbon atom and nitric acid to produce carbon 4 oxide, nitrogen 4 oxide, nitrogen 2 oxide, and water. In the reaction, on the reactant side, the oxidation number of carbon is obviously 0 as carbon is uncombined. The oxidation of nitrogen in triazole 5 acid, which is nitric acid, is simply +5. The oxidation number of the carbon atom in carbon 4 oxide, as the name implied, is +4. The oxidation number of nitrogen in NO2, as the name implied, nitrogen 4 oxide, is nitrogen, and the oxidation number of nitrogen in NO, as the name implied, nitrogen 2 oxide, is nitrogen. So when we check from carbon on the reactant side to carbon on the product side, you see the oxidation number of carbon increased from 0 to +4. Whenever there is an increase in oxidation number, oxidation is said to have occurred. So therefore, the increase in the oxidation number of carbon tells that carbon has been oxidized. Then in the case of nitrogen on the product side, the oxidation number of nitrogen is +5. On the reactant side is +5. On the product side, it's +4 here and +2 here. +5 being greater than +4 means there is a fall in the oxidation number of nitrogen. And whenever there is a fall or reduction in the oxidation number of an element, then it is said to have been reduced. That is to say, in nitric acid, nitrogen was reduced from +5 to +4 and to +2. So therefore, these two halves of the reaction are said to be the reduction half. So therefore, if this is definitely reduction, then this should also be reduction. So that is to say, nitrogen was reduced while carbon was oxidized. That reactant that is reduced is said to be the oxidizing agent, while that reactant that was oxidized is said to be the reducing agent. So therefore, carbon is the reducing agent as it caused the reduction of nitrogen in nitric acid, while the nitric acid is the oxidizing agent as it caused the oxidation of the carbon atom. On the other hand, the next example, we can say that in this reaction is a very, very technical reaction. As you can see, on the reactant side, the oxidation number of lithium is 0 as lithium is uncombined, because the oxidation number of an element is always 0. when it is uncombined, and the oxidation number of hydrogen is 0 as hydrogen is uncombined on the reactant side. Then on the product side, the oxidation number of lithium, being a metal, metals always ionized by electron loss, so the oxidation number of lithium increased from 0 on the product side to +1 on the reactant side. On the other hand, the oxidation number of hydrogen reduced from 0 on the reactant side to -1 on the product side. So therefore, we can say that lithium was oxidized. So the change in lithium is therefore oxidation, while on the other hand, hydrogen has been reduced. But there's a contradiction here, there's a complication here. Reduction is said to be the addition of hydrogen. So if you check this reaction from the reactant side of lithium to the product side, lithium, the difference between the two is that on the reactant side, lithium does not contain hydrogen ion. Then on the product side, lithium contains hydrogen ion. That is to say, from the reactant to the product, hydrogen was added. Please don't mistake this as simply reduction is said to be the addition of hydrogen ion, not hydrogen in all cases. In this case, hydrogen ion on the product side, hydrogen ion was not added to lithium on the product side, but hydride ion, hydrogen ion is a positive ion, which is H plus. Here, the hydrogen that was added is H minus. When hydrogen carries a negative sign, it is not standing as a proton or hydrogen ion, but rather it is standing as an electronegative ion, which is hydride ion. So in this case, hydrogen is acting as an electronegative element. The addition of an electronegative element is termed oxidation. So according to this reaction, the difference between lithium on the reactant side and lithium on the product side is that on the product side, an electronegative element, which is the hydride ion, the hydride, has been added. Here the hydrogen is acting as a halogen, so it is said to be hydride and not hydrogen ion. So the addition of this hydrogen ion is this hydride ion, is termed oxidation. Why the oxidation number of hydrogen reduced from 0 to -1. Then in the third case, on the reactant side, here in this reaction we have nitrogen 4 oxide reacting with water, dissolving in water. On the reactant side, the oxidation number of nitrogen is +4 as the compound is called nitrogen 4 oxide. On the product side, in HNO2, which is diazonitrate 3, the oxidation number of nitrogen is 3. Then on HNO3, which is triazonitrate 5 acid, the oxidation number of nitrogen is +5. So if you trace from the reactant side to the product side, NO2 to HNO3, you will see the oxidation number of nitrogen reduced from +4 to +3. In this case, nitrogen is said to have been reduced, while if you check in the case of the NO2 to HNO3, the oxidation number increased from +4 to +5. So in that case, the nitrogen is said to have been oxidized as the oxidation state has increased. In this type of reaction, if you check here, you will see that nitrogen was oxidized and at the same time nitrogen was reduced. So the oxidizing and reducing agent is nitrogen. In that type of reaction where the same element is oxidized and reduced, the reaction is said to be a disproportionation reaction. In this reaction between aluminum and the chlorine molecule to produce aluminum chloride. Aluminium has, on the reactant side, has a charge of 0. Chlorine on the reactant side has a charge of 0, as the both aluminum and chlorine are both uncombined. When an element is in its uncombined state, the oxidation number is always 0. On the product side, aluminum being combined with 3 chloride ions has a charge of +3, while each of the chloride ions has a charge of -1. So from the reactant side to the product side of the reaction, the oxidation number of aluminum increased from 0 to +3. Because of the increase in oxidation number, we will say aluminum has been oxidized. So that reaction is oxidation. On the other hand, if you check the chlorine, it has reduced from 0 on the reactant side to -1 on the product side. That reaction is said to be reduction. That which is reduced is said to be the oxidizing agent. So therefore, in this reaction, the chlorine is the oxidizing agent, while that which is oxidized is said to be the reducing agent. So therefore, aluminum is simply the reducing agent. Now, the reason for this is because aluminum can be assumed to have lost 3 electrons to the 3 chloride ions. Whenever there is loss of electron, when there's deficit of electron, the oxidation number increases as the number of protons becomes higher than the number of electrons. Remember, protons have positive charges and electrons have negative charges. So for an atom to be neutral, the number of protons must equal the number of electrons. So when electrons are lost, then the number of protons exceed the number of electrons. For instance, aluminum has atomic number of 13, showing that aluminum has an atomic number of 13, therefore having 13 protons and 13 electrons. So when aluminum lost 3 electron, when it loses 3 electron to the 3 chloride ions, then the excess protons will show. Why? Because removing 3 from 13 makes the electrons 10, while the proton remains 13. So -10 plus 13 will give us definitely +3. So on the other hand, adding 1 extra electron to a chlorine atom, where chlorine atom has 13 electrons, has 17 electrons and 17 protons. 17 electrons plus 1 becomes 18 proton, which is -18, and the protons remain 17. So -18 plus 17 will give us -1. And according to the definition, an electron loss is oxidation and an electron gain is reduction. So in that reaction, we can say that the aluminum has been oxidized as the aluminum has lost electron, while the proton has been reduced as the proton gained electrons. In our next class, we will be discussing how to determine the oxidation number of elements and how to name elements, write the chemical formulas of elements. Thank you very much. Don't forget to like, share and subscribe to always get information when we upload new videos. Thank you very much for watching.